Every human alive today will die before any craft they have built could carry them to another star system. That is not pessimism. That is the current speed of Voyager 1, measured against the distance to the nearest star. The method I used to arrive here is not on any list humans have written. It has no name in any language currently spoken on this planet. Observation log. Reaching another star system. There are 7 serious answers. They range from 73,000 years to 400. The slowest one is the most interesting, not because it takes longer, because of what it requires. Let us travel. 7. Chemical rockets. Voyager 1 launched 1977, traveling at 61,000 kilometers per hour, nearly half a century of flight. It would need approximately 73,000 years to reach Alpha Centauri. 73,000 years is longer than humans have had written language. It is not a travel time, it is a geological epoch. The limitation is not engineering, it is chemistry. The Tsiolkovsky rocket equation, written in 1903, makes this permanent. More speed requires more fuel, which adds mass, which requires more fuel. The spiral does not resolve. The energy ceiling of molecular bonds cannot be moved. Chemical rockets carried humans to the moon. They are also the proof, written in mathematics before the first rocket flew, that chemistry will never carry anyone to another star system. I find this a reasonable place to start, and not a reasonable place to stop. 6. Nuclear pulse. In 1958, Freeman Dyson and Ted Taylor designed a spacecraft propelled by nuclear detonations, hundreds of them, one after another. A steel plate absorbs each blast. Shock absorbers convert it into thrust. The concept sounds enthusiastic. The physics are completely sound. 12% of the speed of light. 50 years to Barnard's star. In 1978, a separate British team, different continent, 15 years later arrived at the same number with Project Daedalus. 2 independent engineering groups. Same answer. Project Orion was not cancelled because it failed. A treaty in 1963 restricted nuclear detonations in space, and the political will to find another way did not follow. I was here in 1963. I observed the decision being made. I will say only this: the engineering was not what stopped. The engineers went home. The drawings stayed. The first method on this list with a real budget and active engineering today is not what it appears to be. 5. Laser sail. In 2016, Yuri Milner and Stephen Hawking announced a plan to send a probe to Alpha Centauri within a generation. The probe, a few grams. The sail, 4 meters wide, a few hundred atoms thick. A ground-based laser array generating 100 gigawatts accelerates it to 20% of the speed of light. Travel time, 20 to 25 years. The probe cannot decelerate. It arrives and passes through the system in hours, then continues outward into the void. There is something about this I find, personally, worth pausing on. Arriving at a destination with no mechanism to stop, and passing through without being able to remain. I will return to this, because the question of stopping turns out to be the most important thing on this entire list. 4. Fusion propulsion. Every star in the observable universe runs on nuclear fusion. The Sun has been demonstrating the principle for 4.5 billion years. 600 million tons of hydrogen converted to helium every second, without interruption, without a maintenance window, without a single engineer on call. A sustained fusion drive could achieve 10 to 20% of the speed of light. Alpha Centauri in 20 to 40 years. The International Thermonuclear Experimental Reactor is under construction in southern France, 35 nations, and has not yet produced net energy. The proof has been rising every morning for 4.5 billion years. I find fusion, personally, the most recognizable concept on this list. I will not elaborate on that. 3. Antimatter. In 1932, a particle track at Caltech curved in the wrong direction. Carl David Anderson had found antimatter. When matter and antimatter meet, both annihilate. 100% of their combined mass converts directly into energy. Chemical combustion, roughly 1/100%. Fusion, less than 1%. Antimatter annihilation is the highest energy density the known laws of physics allow. 40% of the speed of light. Alpha Centauri in 10 years. CERN, the most powerful particle accelerator humans have ever built, has produced in its entire history enough antimatter to power a 60-watt light bulb for a few hours. The universe produces it continuously, in the upper atmosphere, right now, as it has for billions of years. The gap between knowing the answer and being able to reach it is not a physics problem. It is a patience problem. I have watched a species approach this threshold once. They did not solve the production problem, they dissolved it, learning to meet antimatter precisely where it already emerged, without ever storing a single gram. They crossed. I find the distinction between solving a problem and dissolving it one of the more important things I have observed. Everything from 7 to 3 tries to cross the distance. What follows asks whether the distance was ever the right problem. 2. Alcubierre and wormholes. In 1994, Miguel Alcubierre asked whether faster-than-light travel was mathematically permissible under general relativity. The answer was more complicated than no. The Alcubierre drive does not move a ship through space. It contracts space-time ahead and expands it behind. The craft sits in a bubble of flat space, in freefall, experiencing no acceleration, no time dilation. The bubble travels at any speed the mathematics allow. In 2023, a theoretical analysis suggested a subliminal version may not require exotic matter at all. And then there are wormholes. Kip Thorne demonstrated in 1988 that traversable Einstein-Rosen bridges are not forbidden by general relativity. The ER equals EPR conjecture proposes that quantum entanglement and wormholes may be physically equivalent, every entangled pair possibly connected by a thread in space-time. In 2022, Google's quantum processor simulated that geometry in a quantum information system for the first time, not a physical wormhole, but its first experimental appearance. These methods do not cross the distance. They propose the distance was never fixed. Every method from 7 to 2 is competing to cross that distance faster. Point 1 has decided the race was always the wrong event. 1. Generation ships. No exotic matter, no new physics, no engineering breakthrough required. A generation ship is a rotating cylinder. Artificial gravity through centrifugal force, closed ecosystems, nuclear or fusion power sustained across centuries, at 1% of the speed of light, 420 years to Alpha Centauri. The people who arrive will not be the people who left. They will be descendants, born in transit, who have never seen the planet that sent them. They will know Earth only as a direction. Every other method on this list is trying to preserve the traveler. The generation ship is the only one that accepts the traveler will not be preserved and asks what might grow in their place. That is not a concession. That is a different hypothesis about what the journey is for. Of the 3 civilizations I have observed that chose this deliberately, none are remembered for reaching the star. Faster options existed. They chose this for what the crossing required of them. What arrived was not what departed. Humans are, and I have spent considerable time finding the right words for this, the only matter that learned to miss a place it has never been. The distance to the nearest star system is 4.24 light years. That number describes the problem. The generation ship reveals that the problem was never only about the distance. 7 methods, 1 direction. The numbers move from 73,000 years to 40 to 400. Not in a straight line, because this was never a straight problem. Chemical rockets defined the wall. Orion proved the wall is partly political. The laser sail proved that arriving without stopping is its own kind of question. Fusion points at the engine. The universe has run for 13 billion years. Antimatter sets the highest energy ceiling physics allows. Alcubierre and the wormhole propose the distance itself is negotiable. And the generation ship asks the question none of the others thought to ask. Not, how fast, but what are you crossing for? At every point on this list, the barrier was not the science. I came here. I had a method. It is not on this list. What I will say is that the question this list ends on was the only one I was not prepared for, and the only one that mattered. The distance was never the hardest part.